Hi, I'm Bill Hanneman, and today I'd like to show you something that can make a big difference to your reed making. I'm going to demonstrate my method of hand rolling a custom staple from sheet copper. Now you might ask, why would I do such a thing when I can get a perfectly good brass tube staple from the shop? Well, if you have a Uilleann chanter or any of a number of modern chanters, no reason at all. This is the perfect staple for many chanters. However, if you own a Uilleann chanter, a chanter made before 1980, a Kohler and Quinn chanter, or any of a number of other instruments that actually require a different size staple, you're going to want to roll your own. Since the staple is in effect an extension of the bore, very small changes in the staple can make a big change in the performance and tuning of the chanter and reed. I would caution you that even commercial tubing like this can vary in its inside diameter from as large as 4.1, 4.2 even, to below 4 millimeters. So it's something to keep an eye on even if you're using commercial tubing. You may find, for instance, that difficulties or even things you thought were chanter faults seem to disappear with the right staple. Right, so here's what you'll need. First of all, you'll need copper. This is pure copper sheet. It's 20/1000ths of an inch thick, or 1/2 millimeter if you prefer. It's just over 2 inches wide. I've cut a piece here that's about 54 millimeters wide. You'll need a metal surface. This is actually a bit of mild steel. I recommend steel for this. It's not a mirror polish, but it is nice and flat, and you will want it to be flat and reasonably stable. Now, this is an ordinary shooting board. I bought this from NPU many years ago. If you turn your shooting board over, you may find that there's a slot or a groove in the back. And that's what this groove is for. It's for rolling staples. If your shooting board doesn't have one, you can either make one yourself or make one out of another piece of wood. In a pinch, you could probably use a piece of tongue and groove flooring, flipped around and maybe finished a bit on the back. Basically, you need a groove that's just over 6 millimeters wide and 3.5 to 4 millimeters deep. It's rounded on the bottom. That's preferred, but not absolutely essential. This is a little bit of boxwood that has been formed into a wedge, and as you see, there's a groove that's been filed into the end. And I use this in order to help press the mandrel into the groove. If you don't have access to the right tools for this, you can actually make a reasonable one out of an old wooden ruler. You'll also need a file to adjust the sides of the staple blank. This is a nice, relatively new file. This is an old battered file that actually barely has any teeth on it. This is a very good tool for actually rolling the staple copper around the mandrel. It gives a nice grip. It's a good hard piece of steel, and it also leaves behind just enough texture on the finished staple to help it grip the reed binding. You'll need a hammer of some sort. This is a hammer made by the Thor Hammer Company. This is their smallest size, size A. They make sizes 1, 2, 3. They're mostly too big. This particular model has rawhide on one end and copper on the other. You'll need a vernier for actually measuring the blank. I like an old-fashioned vernier caliper rather than a digital caliper, mainly because the batteries last forever and you can drop it on the floor and it still works. You do want to make sure, however, that it's accurate, so you want to push this together and make sure that you're actually reading 0. Because we are doing something precise, you want it to be a reasonably good quality vernier. We'll need a mandrel for flattening the staple. You probably already have one of these, and we'll talk about this a bit later. This is another type of hammer. If you don't want to go out and get a Thor Hammer Company hammer, rather than using an ordinary household hammer, I would recommend getting something a bit smaller, maybe with a shorter handle, just because the goal here isn't to bash things as hard as you can. We're trying to use this as a precision tool to help shape the staple. So having something a bit smaller or lighter is actually quite helpful. This is the part of the kit that is probably going to be the most difficult to come by if you're not a machinist. This is the rolling mandrel. It's a tapered steel tool. It can be made out of hardened tool steel if you like, but it can actually be made out of something a bit softer because we're really only asking it to form soft copper. So I'm not sure there are any shortcuts for this. I have heard of people making them with kind of some way to rotate this around its axis, like a cordless drill or something, and a file and abrasives. It will certainly tax your patience, but it is important that the dimensions be correct, and we'll talk about what. I'll give you some suggested dimensions later. And it's also important that it be nice and round in cross section. So this is an important part of the kit. If you make staples in a lot of sizes, as I do, you may want to have a way to mark those staples. And for that, I actually use a set of number punches, which we'll see later, but those are quite optional. You'll need some sort of tin snips, or even a super heavy pair of scissors like this. Or a bench shear. I'm actually going to use a bench shear because it gives a nice, straight, precise cut, but there's no reason why you can't do this job with the heavy scissors or with a pair of tin snips if you take your time and are careful. Now, before we try and roll it, we'll need to soften this metal. The process of rolling metal sheet tends to harden the metal, and so in order to make it more malleable and to ensure that it conforms to our rolling mandrel, we'll need to anneal it. And by anneal it, we mean heat it up to the point where it just begins to glow, and then let it cool to room temperature. So, I'll set my vernier to 600 thousandths of an inch. That's 15.2 millimeters approximately. I'll make a mark. And then on the other end, I'll make another mark at 13.7 millimeters or 0.540. Next, I like to use a scriber of some sort. Because this copper is quite soft, I'm actually going to use a knife. And I'm going to make a line. on the copper. I'm going to gently reshape this staple by tapping it or rubbing it on the metal. And again, you don't want to get too carried away. You're just trying to iron it flat. You're not trying to thin it or hammer it. All right, now that we have our staple blank approximately the right size, we want to measure it with the calipers, make adjustments with a file, and then we prepare to do the actual rolling of the staple. I've put some leather jaws in this vise, and I'm putting my good file here so that we can bring this to size. And it's best to flip and do it again. Now, if it was way oversized, I'd actually put it back on the bent shear and trim it a little bit more. It's always nice to be oversized at the beginning. .55 on 0.61. So they're just about 10 thousandths over on both sides. Now, if one side was considerably oversized and the other side was almost correct, then I would utilize a little trick. When you file something in this direction, the leading edge always tends to lose more material than the trailing edge. So you want to lead with the side of the blank that you want to take more material off. If it's the same in both directions, then you want to flip it around and lead both ways. When I'm doing this, I'm trying to keep the blank fairly flat in my fingers. I don't want it to crumple up because that'll interfere with getting a nice straight side. 0.540 and 0.6, maybe 0.5. So I'm going to take more off. This end is just about right, and this end is a little bit wide. So I'm going to lead with the wide end. And if you're wondering, how much makes a difference? I find that 5 thousandths of an inch in the blank is enough to make a noticeable difference. So I try and get it within, say, 3 or 4 thousandths of an inch. That's about, so yeah, 1/10 of a millimeter anyway. I try and get it within 1/10 of a millimeter of the correct width. Right, so this is our final size. Right, Now, we've got our blank. We're placing it over the slot with the number on the bottom. Make sure it's centered well in the slot. And now we're going to give it a gentle tap. Just to start settling it into the groove. Then we take our little piece of boxwood, and that forms it into something that's approaching a U shape. It's best not to go all the way closed at one end. It's better to try and slowly bring the copper around a little bit at a time. And we want there to be a gap at this stage because the gap is closed by the rolling process. If we start at the wrong part of our rolling mandrel, or if our copper is too wide, it'll overlap and that will spoil the staple. So we need to make sure that we're at the right part of the mandrel, the copper doesn't overlap itself, and there's a bit of a gap. That looks pretty good. And at this point, we can start to roll. Gently at first. And then more vigorously. Now here's an interesting conundrum. If you always were making the same size staple, you would know, based on the diameters of the finished staple and the size of the blank, you would know exactly what taper and what starting diameter and what ending diameter to put on your mandrel. But in fact, I make several different sizes of staple, and because I tend to hold the eye the same size and change the wide side, they don't all have the same taper. Perhaps in a perfect world, I'd have half a dozen rolling mandrels of different tapers. But it turns out that you can roll a tapered staple of a less steep size on a steeper or a more steeply tapered mandrel. And I'll show you how. As the seam closes, we'll gradually slip the copper blank forward on the mandrel. And because this mandrel is slightly more strongly tapered than our finished product, it'll close at the front first. So we keep gradually edging it out. Until the front closes, and then once the gap closes, we will no longer put force on that part of the staple. So as it closes, we move our force back on the staple so that we don't smush an unsupported part. There we go. So I'll go through that again. We start with a gap. We roll until the front end closes, and then we gradually push the staple forwards as it closes, putting our rolling weight towards the back of the staple and avoiding any section where the gap is already closed. Right, we've got our cone. Now I'm going to show you how I form the eye of the staple with a seamed tube. Because there's nothing holding this seam together, we have to take some extra care that it doesn't spread apart when we hammer the eye. You'll also notice that at the narrow end, this staple is actually a little bit smaller than our mandrel. So we make sure that the eye is in the right orientation so that the seam is right in the middle. And we just gently make it oval so that we can get the staple inside. Now, my method involves pushing the tube all the way onto this mandrel so that we're into the round section. And I'll take this opportunity to discuss this mandrel in more detail. You'll notice that this mandrel, as I turn it in the light, it doesn't have flats on it. It is in fact a smooth kind of lens shape in cross section all the way down. And that's important. If your flattening mandrel has flat ground surfaces on it, it's not going to be a very good mandrel for this kind of work. You really need a mandrel that has been carefully shaped so that at each point from where it's round, it gradually becomes more and more oval. If your mandrel doesn't look like this, get yourself some files and some abrasives and remodel it until it does. Here we go. Seam is carefully arranged, lined up. And now, by gently stroking the copper with the copper side of the mallet, I'll push the edges together. I'll try and avoid hammering directly on the seam. The seam doesn't need to be hammered. We want to hammer on the 45-degree edges. So as I hammer, I'll gradually pull the mandrel out so that it flattens in stages. Notice that I'm turning it, turning it, turning it. And then when I get closer to fully out here, I'm going to hammer on the other side gently. And now again, you see the seam is just beginning to spread. I'm going to push it back together like so. Once you're done, you can take your good file and gently wipe across like so to eliminate any lumps, bumps, or irregularities in the outside of the staple. If there are lumps or irregularities in the staple, it can cause a bit of a stress concentration and make it more likely that your blades will crack when they're tied on. So this is the last step in forming the outside of the staple. So there you have it, a finished and rolled staple. The last thing is to deburr the inside. You can do that with a little knife or a deburring tool. Or you could use a small file. And you can deburr the outside. And you want to make sure that there's no sharp edge here to tear up your reed seat and bore a hole into your chanter. So I always round over the edge. Make sure it's not too sharp. So you made it this far, or maybe you skipped to the end. I promised a bit of information I'll tell you about where you can go from here. First, the mandrel that I use to form these staples. As I said, it's not a perfect fit for that staple formula. It's slightly more strongly tapered. The section of the mandrel that is of most interest to concert pitch reed makers goes from about 4.7 millimeters at the large end to 3.8 millimeters over a distance of about 75 millimeters. Or you can design a mandrel that's a perfect fit for your staple blank by working out the correct inner diameter of the staple from the width of the staple blank. Here's the formula. To get the inner diameter of a staple from a blank, take the width of the blank, divide by pi, which for our purposes is just 3.14, and then subtract the thickness of the material. You'll see then, if you work it out, that the large end of that staple we made today is 4.35 millimeters in inner diameter, and the small end is 3.865 millimeters, just under 4, which we already noticed when we tried to put it on our mandrel. Sometimes I even go as large as 15.75 millimeters on the wide end of the blank, and that yields about a 4.5 millimeter inner diameter staple, quite large. In general, a wider staple will produce a wider octave, and a narrower staple will produce a narrower octave. By wide octave, I mean that the second octave is sharper than the first, and a narrow octave would mean that the second octave is flat relative to the first. So wide and narrow refer to the distance, so to speak, between the two octaves. I'll leave you with a few other suggested dimensions for different types of chanters. I found that many coin and canard chanters can be reeded with a staple between 48 and 50 millimeters long and a blank that is 12 millimeters wide at the narrow end and 12.3 millimeters wide at the wide end. I make these out of brass at 0.4 millimeter thickness. Remember, a different thickness of material will produce a different inner diameter for the same blank size. I use brass for these staples because 0.4 millimeter copper is very soft and not strong enough. The Uilleann staple blank that I suggest goes from 12.7 millimeters at the narrow end to 13.2 millimeters at the wide end. It's about 55 millimeters long, and in some cases you want to make this taper in reverse. In other words, you form the eye at the wide end of the tube and not the narrow end. That's tricky, but you can do it using the methods that I showed you with the mallet. Good luck and happy rolling.